This video is brought to you by Munro Associates.
From new product development to teardown benchmarking, Munro offers comprehensive solutions. We specialize in reducing cost and weight, drawing from 35 years of experience to help you maximize profitability and elevate your projects. Contact Munro Associates today, and let's turn your next project into a success story. Munro, innovation starts here.
Hey everybody, we're over here at Land Industries, and I'm here with Scott Calissimo, right?
You got it.
Got it. Okay, so good. And today what we're going to do is we're going to talk a little bit about their electric motorcycles. Now, I used to drive motorcycles. They were big, heavy, and I couldn't get dates with them. This is going to be the new era of motorcycles. These ones are light, fast, cute, and as another motorcycle company used to say, you'll meet the nicest people on a land motorcycle. Is that correct? Yeah.
I think so, yeah.
Well, Scott, thank you very much. And why don't you describe a little bit about what I just was pointing at here?
Sure. So I think the first thing to understand is that our group has a lot of experience in vehicle manufacturing, gas vehicles, traditional ICE, cars, motorcycles, and that this is kind of, in our opinion, the next expression of where two-wheel motorcycling is going. We are kind of your dyed-in-the-wool motorcycle folks that have just seen a different way. And the way that I put this is, when your only tool is a hammer, everything looks like a nail, right?
Yeah.
And we look at this as a tool, right? If you want to go cross country, you're probably not going to do it on this, right? You'll pick a different tool. But if you're looking for lightweight, fun, a ton of torque, around town commuting, and just some off-road blasting, this is a very good tool for that.
Well, one thing that we should mention too is I see no gear shift anywhere in here. Why don't you talk a little bit about that?
Yes, I think that's something important to mention. Our group is very focused on usability, right? We're really focused on what gives the customer more value. And we did about 2 weeks of testing on everything from your traditional gas dirt bikes to everything electric that was out at the time. And when we reflected on our experience of testing everything that was out there, we asked ourselves some questions like, did the shifting actually give us a better experience? Did the clutch give us a better experience? Did the foot brake give us a better experience? And what we came away with is our lap times weren't any faster. To keep the traditional kind of motorcycle paradigm in the electric field made no sense. But to make this twist and go and to put the brakes on the handlebars actually gave us, in some cases, faster lap times because your foot wasn't captured.
Right.
It made it more usable. We had people that hopped on the electric vehicles that immediately were comfortable with riding because they didn't have to worry about letting off your clutch slowly and then focusing on lightweight, low seat height. There were a lot of things that we really focused on to make this more usable. And by doing that, it's more usable to the new rider as well as the kind of dyed-in-the-wool motorcycle community.
Not only that, it's fun. It's no fun to learn how to clutch, shift gears. Is it 3 up or 4 up, 3 down, 5? All that stuff goes away. That base knowledge that used to say, wait a minute, I can't find neutral. That stuff, leaving that behind, I think was a great idea because every motorcycle had a different way of making it happen. And for me, going from a BSA to a Triumph to a Kawasaki, and then ultimately to, I went backwards to another Kawasaki, but in the middle there was a Honda. At the end of the day, you get used to it, and it's kind of cool that you've got something that you don't have, that other people don't have, like a manual shift and stuff like that. How many people do that? Nobody. I mean, so moving to this, just like the electric vehicles, like electric cars, there's no gears. You get on it, you can ride a bicycle, you'll be able to ride this.
So what we've done though is, because this is software defined, right? It's software defined hardware.
Yeah.
We added ride modes. So what you get is a vehicle now that has ride mode 1 that is a bicycle. So it's limited to 750 watts and you could ride it as a bicycle. So if you have a new rider that wants to safely get into riding, you can set it to ride mode 1. If that's not enough for you, we've got ride mode 2, which is moped mode. So it maxes out around 2 horsepower. So it's more than double ride mode 1. And then ride mode 3 and 4, ride mode 3 is what we would call like a commuter motorcycle, around 20 horsepower, torque limited. Ride mode 4 is still somewhat limited, but almost unlocked. So now you've got one vehicle that through the software can be different things to different people at different times. So while you're not shifting through gears, you can focus on twist and go in the brakes. But let's say you want to hop on a slow trail, you don't have a 40 horsepower motorcycle on a small single trail if you don't want it.
Yeah.
So the software is really what is defining what this is at the time that you're using it.
Yeah, but it's one push of a button.
That's it.
Versus every time you come to a stoplight.
Yeah.
Yeah. Okay, good. So anyway, now we've got a kind of an overview of what it is that you, what you're producing here. We're standing in your R&D area, and it looks like you've got lots of sketches and lots of ideas. Why don't you tell us, oh, I know that. Anyways, why don't we talk a little bit about where you are and where you're headed?
Sure. So we have a lot of expertise in motorcycle manufacturing. I started a motorcycle manufacturing company in 2008. We scaled it to 2020 and sold it. So we've designed and developed about 12 motorcycles from the start of that to the end. So the core competency from our team is design, engineering, design for manufacturability, and manufacturing. So as a core competency, that's kind of where we started. So we had a lot of freedom when it came to, we weren't figuring out how to do that. So a lot of our focus went on, how do we make this a better product for the consumer? And as you see here, you know, there's thousands of sketches to get to the first prototype. There's dozens of prototypes to get to your first, you know, call it beta, and then to get to production. So what we focused on here was, what was the whole industry doing wrong? And there's a few, I would say, core beliefs that led us to where we're moving, which is the battery being a separate component from the vehicle. And so this is like first gen where the batteries swap. So this is our larger 6 kilowatt hour battery, and this is swappable, a lot heavier, but the American consumer wants torque, they want power, and they want range. So this one battery will give you up to about 120 miles of range. Now, what we're doing is moving our focus to a more user-centric battery now. So you can put one of our smaller batteries, which is about 40 to 50 miles of range, 2 of the smaller batteries, or the one big battery. And as you see, we're moving to a hot swap connector. So away will be the, you know, your traditional wire connectors.
Top side.
So now
connectors.
What we've got is our first vehicle platform. This is both on-road and off-road. If you pan to your right here, we do have a strict off-road platform that we are using with this. And now we've got a battery platform that is scaling our second, third, fourth vehicles. And now this IoT battery platform are going in other people's e-mobility and light electric vehicles.
Well, that's something that we should probably address, in that you're making motorcycles and you're making batteries for your motorcycles, but you're also making batteries that are going to go to other people, other products, maybe light electric, bigger than a golf car, but not a real car kind of a thing. So why don't you talk a little bit about where that market's heading?
Sure. So because we were so focused on the lean aspect of the manufacturing, what we really wanted to do is develop a platform where we could double, triple, or quadruple the big battery. and get 200 plus miles of range from the big battery in a light electric vehicle, or we could go down to about half this size for bicycles. So on the energy side, we were focused on everything outside of the car. Now we're not going to do a kind of entry-level bicycle, but 1 kilowatt up to a platform that could be 50 plus kilowatt hours. So we've got a scalable platform now that works in multiple arenas. And because we've got IoT and compute built into the batteries, now we've got a smart platform. It's like, well, where does that go? Well, now we can manage energy use, right? Now we can manage, the battery can self-manage its longevity, right? Hey, let's not charge it to this peak if you want it to last 5 years. Or if you're in a race application and you don't care about degradation, we can safely release all that energy as quick as possible. So the platform that we've developed was really focused on being agnostic to just our vehicles, but also being connected. So now we can do over-the-air updates through the battery, which is a very unique value proposition.
So on here, did I hear that? Because that's the first time I heard this. Can you get to like a C3, 4, 5 kind of standpoint? Can you get to C5? Because that's where the problem lies for VTOLs, vertical takeoff machines. Is I need a tremendous amount of power at the beginning. Once I'm up in the air, I can depend on the wing, and I'm pretty good. But will this work in that application?
Yeah. So let's talk about amperage.
Yeah.
So on discharge, even the small battery can do 200 amps continuous. So we can peak much higher than that.
Yeah.
But that was our focus, is very high amperage. So when you start with a high amperage rate with a small battery like this, and you keep it lightweight, 27 pounds, there's a lot of optionality there. Now, we've got some advanced projects that are much, much higher than that. I would say the limit on C rate for us is if the batteries are hot, recharging. So what we're trying to get is the best of both worlds. You're trying to get a very fast recharge rate and a very fast discharge.
I want to have a look at this part right here. And you need to come up close, Grace. See these welds? See these welds right here? These are as good as you can get. See that nice fillet? See over here this nice radius? This was done by a master. Now, initially, when I saw this, I put my hands on it and I'm thinking, this is great robotic welding. But it ain't. It's him. Josh, why don't you tell us a little bit about what you were doing here?
So basically this is how we started to ramp up our production. So each subassembly over here, I weld, I tack it and weld it, make sure it fits back in the fixture, and then I put it on that table to do like a final tacking, pull it off, and then I fully weld everything.
But this is a great example of kind of the resilience of a startup. So the last gas motorcycle we made was about $2.5 million in tooling, because 10 years ago, everything was cut a big chunk of steel, weld it together, and then we would have a whole room of tooling fixtures, right? Well, these Sigmund tables are a relatively new invention. Josh said we can get a lot leaner, because this wasn't going to be throughput of 50,000 units a year, right? This was going to be scaling up until we got it on a robot. So Josh, Evan, Henry developed a system to be super lean, to be able to basically do several hundred units on these Sigmund tables. That saved us, because if Josh, Evan, and Henry didn't set this system up, it took us over a year to get our robotic manufacturing up and running in the US. Now, we were talking about, it's not our desire to do everything in the US. What US manufacturing does for us is it helps us with cost of capital, because we could reduce our supply time, helps us with quality. If there's an issue, we don't need to fly to China. We drive 20 minutes down the street. So we're not just banging on the American drum. What we're doing is leaning up the manufacturing process to where we can make more product quicker. But what's happened in the US for the last 35 years is all of the castings, the forgings, all the expertise has been stripped out. So what we're finding now is a renewed vigor for manufacturing and a real desire to keep American manufacturing moving. And while the desire's there, the expertise isn't always. So in China, it would have taken us about 15 to 30 days to move from prototype to production, because there's 100 robotic manufacturers I could have went to that are already doing this. In the US, we had to partner with someone that was willing to invest in new equipment, expertise. So what it took to go from zero to a finished product, I mean, I would say it's about a year and a half.
Probably close to it, yeah.
About a year and a half of trials and tribulations to get a acceptable robotically welded chassis domestically. And think about it, like, we're kind of one when it comes to motorcycle manufacturing, at least people that go this in depth, right? The market is still very much, you source all of your components and you kind of lightly assemble. So to go through this process was eye-opening, and thank goodness we have a team that's nimble, thoughtful, and understood that we've got to get in production, because if they wouldn't have gone through this process and we would have relied on a supplier, we would be gone. We would not exist today.
Well, I will tell you one thing. What we're sitting on here, you have a name for it I've never heard before. But for me, this is a pin table. A pin table, I have one in...
Sigmund's, this is the brand we chose.
Oh, okay. So we at Munro have 2 pin tables. They're quite a bit heavier than this. And one's stamped 1935, and the other one is stamped, I think, 1928 or something like along that lines. I got them because people were throwing them out. And the reason that they were throwing them out is, oh, we never do that. What we do, and the basic answer is, we just ship that out, somebody else does it. Without one of these, you can't do these, you can't do that. You can't figure out how you're going to do it in a production
This got
environment.
us to mass production.
This was the very first thing that we bought.
And that was a good buy.
It was the very first thing.
Yeah. And that was because Josh is like, I absolutely need this as a tool that we could build off of.
Yep.
Right.
And even the thoughtfulness that the team have in developing this is like extrusions that we just need to lightly surface. So even the way they design the tooling is completely flexible.
Yeah. Plus, when we're done, we can throw it on that little rack, and then everything's out of the way.
Right.
You throw another set of...
I think my favorite thing about what you see on this table is, early on we didn't have a lot of resources. So like I was saying, this was the first thing that we bought. And the second thing was one of those 3D printers that was in our lab. And what you see here was all 3D printed, and we actually made the first 7 prototype chassis on 3D printed fixtures before we learned how to do CNC in-house and really...
Do we have any of those left, or are those all gone?
They're probably in
we have one
archives.
piece.
There's a couple at the bottom.
Yeah, so here, so that's, just think about what he's saying. We made the first prototype chassis off of 3D printed fixtures, which took us a half day, sometimes 2 days to print. And once we got that right, then we cut aluminum, right? So think about how lean this process is. And that's one thing that we are very heavily focused on, is because we don't have a lot of money, right? You see all these startups just burning through it.
Yeah.
We had to be very lean from the way we thought about how we designed to how much we had to tool up to get into mass production. And then once we were in mass production, we're still using some CNC components. Now we're doing the 100,000 into forgings and castings. Now that we're at a scale, we've gone from this to robots to forgings, castings, injection molding. And that is one thing that I think is so brilliant about the age we're living in right now. The tools we have to manufacture have brought the cost down exponentially, at least until we get to 50,000 units a year, right? We have the ability now to scale this up in the US, which we never had before.
So at the end of the day, what you had is what I call the luxury of adversity. Couldn't get any money.
It's a luxury.
Couldn't get anybody to build it for you. And quite frankly, I know, you don't even have to tell me, this wasn't your first set of ideas. And when you have the luxury of adversity, you have the ability to see the mistakes that you've made and know that, hey, I can't do this twice like this. Okay, so, like I said, I was a tool maker. I had to weld, and I could do way better than this, and way better than that, and way better than this. And all these scarfing things you see, those are mistakes that somebody tried to fix up with a grinder. I cannot believe the difference between this bump on a log, basically is what we used to call that, and what I saw over there on the handmade version. And this is robotic?
Well, and that tells you how difficult it is to go from like 0 to 1 in the US. Now, Josh has worked with the supplier intimately with our team for about a year and a half, and the welds we have on production, you should see. They're beautiful, and I believe you even worked on pulse and cold metal transfer.
This is another first. These are first, like the 2 samples we got. We're just using them for like prototyping.
Parts fitment.
Yikes.
But the good thing is now that the manufacturer was willing to work with us over about a year and a half, we've got the quality on this. It's repeatable. It's where it needs to be. The heat transfers down. This pulling, like none of this is happening anymore. But
this should never happen. Okay, I worked for Nucor. Nucor made welding machines. We made spot welders. We made arc welding, a variety of different arc welding, TIG welding. We did it all. Mm-hmm. And the machines were huge. You could not put in one of the machines that I worked on in your whole factory. It would eat it all up. And guess what? When we turned on a welding machine using old-fashioned technology, old-fashioned robots, it came out a whole lot better than this. I think that there was just either a reluctance or oh, well, just get the damn thing done and shove it out the door. That's another one of those things that I have a real problem with. It used to be that Americans had a sense of pride, and I'll tell you what, I would never show that to a customer. Never in a million years.
Well, the good thing here is by pushing and working together, this supplier now has a core competency that they did not have before we showed up.
And you trained him, but he didn't pay you. All he's doing is giving you what you asked for originally. He's probably charging you more.
Well, I would say they probably invested they invested millions in tooling and the machines. So we were willing to work with them because that was a capital investment.
So they bought the machines to bring them up to the level that they should be?
Well, yeah, I mean, when I say they went from 0 to 1, they went from traditional hand MIG welding to robotic welding with us. So that's one thing I want to say to give this supplier credit, is they stuck with us through the trials and tribulations of learning how, and mind you, coped round tube is one of the hardest things to weld.
I'm aware of it, but
they stuck with us through this, and now we have a very competent product that we are able to move from skilled welders 2 a day to a robotic welding operation can do about 1 every 8 minutes.
Yeah.
So,
and that's the way it should be.
So
now,
luckily, just to add a positive to where you're at, we got through this, and mind you, the reason these aren't on production bikes is because they were not acceptable to our supplier or to us.
Yeah.
But we were pushing them to see something.
Yeah.
And when we saw this, it was a bit of a shock. But you know, that is something that is very valuable now to us, because now we have a new supplier that can do this for us based in the United States.
And that's good news. And if they can do the job right, and they went in and invested in the future, that's good. That makes them kind of like, oh yeah, the Chinese. Because the Chinese never use old crap. You walk into a Chinese tool shop, everything was from Japan, from North America, from the United States mostly, Europe. They use those machines. The Chinese stuff, the Chinese machine tools, well, they sell those to the United States. But this is one thing, but I also, when you told me the story about this, I about peed my pants as well. So, all we do is laser cutting. Oh, all we do is bending. Oh, all we do is is some welding. Oh, all we do is whatever. These kinds of things where I'm moving it from shop to shop to shop to shop, all you get is scrap.
Yep.
Poor quality and...
The finger pointing, yeah.
Exactly. Why don't you tell us a little bit about this, because I'm going to use this in one of my speeches.
Sure. So this is, again, educating ourselves on working with the supply chain that we have here in the U.S. Because we have been in the manufacturing business now for, a few decades, when we really started looking hard at our U.S. supplier base, it is very much my core competency is laser cutting. My core competency is bending or folding. My core competency is anodizing or surface finish. And what happens is you get one factory that lasers, shipped to another factory that bends, then shipped to another factory to finish. And a lot of the suppliers and the OEs we talk to here don't understand that the Chinese have really moved past that, where they have vertically integrated and they've understood what the end consumer wants, what their end B2B consumer wants, which is a no-hassle final product that meets your QA/QC requirements, right? So we then have one manufacturer that is willing to do in-house the laser, moves it right next door to do the bending, and then do the finishing, and provides us with a product that's QA/QC'd to the nth degree that meets our exact specification. So there is a bit of a difference in the US how we work our supply chain here, because it's just a different mentality, which is like, nah, I just burn. I burn plate. Or I just water jet. So what we're looking for, and again, I try to look for the positive, and hopefully this broadcasts enough that we find suppliers in the US that say, hey, we can help you with that full supply chain. Because what we were finding is, the laser cutter gouges the steel.
Yeah.
Right? And then they're not talking to the bender, who then is bending our aluminum on steel dies, right? Or steel jaws, which is then marking them up. Then the finisher gets it and says, I can't finish this because the part's destroyed, right?
Yeah.
So that's where we're at, where we're trying to find not just manufacturing, but folks that understand that like the final product, the surface finish, the QA/QC, all of it matters, right? It's not just is it bent to spec.
Yeah, and how we design our vehicles, you have a lot of parts that are what they are. We don't hide a lot of stuff under plastic or panels or things like that.
Yeah.
So, to build on what Scott was saying, is when we have marred surfaces on our sheet metal, it really becomes a non-option, because we can't move forward in production with it, because the parts are the parts, and that's the beauty of what we do here. It's really showcasing the design and the material.
So Scott, why don't you tell us a little bit about the modularity you've got here? I see back here power supplies, and over there I see the frame. Here's the assembly line. Why don't you give us a lowdown on that?
Sure. So we're obviously limited by space and height here. Having an old building that we are scaling up production. So what we did was first lay out the facility so we knew where everything was coming in, QA/QC, QA/QC points to ship in, final goods go in the back, everything moves forward to sub-assemblies, sub-assemblies get put together, and then it comes to the final assembly line. Because of our space limitation, we're limited to around 12,000 units a year here. Mm-hmm. So, and that's really just because of where we're sitting. But that is really what we're moving to. And our current limitation is actually not expertise, people, or space, it's capital. So we have enough capital to do, biggest month was 42, lowest will be about 30. So we're doing about 30 to 40 a month. But as you know, CapEx and everything that you need to scale up manufacturing takes capital. So what we're doing with the limited capital we have invested right now, we've built out a facility. It's a great place to work, as you can see. We're assembling on the floor here, and it's fairly quiet. Everything on this side is clean. So we've got different areas which are dirty. We'll do grinding, welding. Right. But out here on the final assembly floor, it's clean. We start with our power unit. So obviously the lifeblood of any vehicle is what makes it move. So we attach our motor controllers and all of our electronics. We spin them up, make sure they work, because if they don't work, it's very easy to disassemble at this point. And then as they go through, there's different stages of production here.
Let's have a look.
Yeah, so as you can see, as we pull things forward, power assembly gets put on. The chassis then gets married with the battery box, the motor, and the inverter. And Joe, about how many steps do you do at this one station here?
At this station, I do the frame onto the battery box. I put on the bodywork, the seat, the rear fender, and then it moves forward.
Okay, so you got 5 to 6 on this station. And that's the other thing, is this is ebbed and flowed. We had a lot more stations to begin with, but we found that we didn't need that many. And like, let's talk about some of these components. The one thing that we noticed is this change from solvent-based paint to waterborne paint. Europe has made the transition a decade ago. US is in this process now. We were having a lot of issues with paint, and looking at this more like a durable good, the team decided to switch to mold-in color.
Perfect idea.
So we're trying to take this away from like a precious jewel box and move it to more of a durable good. So what we did is a nylon-filled injection molding process. And Joe, do we have any colors on the line now that we can show? Oh, right here. So you can see our injection molded white, and then we've got our green here. But like, look at the vibrance of this, and by keeping them matte and by doing mold-in, there's no further processing once they get pulled off the mold.
Perfect.
And we actually embraced some of the striations, like the stuff that injection molders try to remove, we didn't mind.
So in the light, this might be able to catch it. You could actually see the glass strands.
Yeah.
And we always we like the materials and
We
the
embrace the
manufacturing, the
process.
processes of
Yes.
it. And not only does that look cool in our opinion, but it also helps with scratches in the future, so things aren't as obvious when it becomes a durable good.
No, this is a perfect idea.
It
I
wears
love
in.
anything that doesn't require painting, because as far as I'm concerned,
Painting,
paint is bad.
Yeah, it was a whole saga for us.
And the consumers that we have are embracing this, saying, you know what, I really like the process of how you make this, and why don't we show it? And that was a big step forward. So a lot of what we're doing right now is looking at, well, how do we add value but also reduce complexity? And these parts are 4 times as strong as an ABS injection molded equivalent because they are the glass filled. So these are very, very strong parts now.
Oh, I'm all in. I think that's a great idea. Also like the ergo tables. Bringing it up and down makes it easier for the operators. And some people don't catch on that, but this couldn't be better.
Well, this is good Midwest ingenuity. Early on, I went and visited Eric Buell in Wisconsin at his plant.
Yeah.
And when I was doing gas motorcycles, we had a trench, right? We had a moving assembly line with fixtures on it. You had your numbers up top, and you wanted to do more, you'd sped it up. And Eric's like, all I need to do to increase production is we add 5 more carts.
Exactly.
He's like, there's no this, we don't need to stop the line to add. So this was looking at how someone else was doing it. And I think Buell, when they were really cranking, they were like 36,000 units out of a 40,000 square foot facility. So we looked at that and we said, well, this is a great way to ebb and flow. And if, let's say there's a QA concern that we see here, so there's a quality concern, here's all we do.
Yeah.
You move it, and production continues.
Right.
So
we call this a non-synchronous assembly line. And when I design any assembly line, I make it work like this. I might make it automated. I might put motors on these things so that the operators don't have to pull them around. But for this, the weight isn't a real big issue. So
the final vehicle
moving
is
them,
200 pounds. So
it's nothing compared to maybe moving a car. You wouldn't want to do this, but for this, piece of cake.
Well, and what this gives us too is flexibility. So until we really had the process figured out, there were many reconfigurations on the factory floor here, and this gave us the flexibility where we weren't stuck. So as you see, as it goes, there's more sub-assemblies that come. This is, I think, one thing that we want to focus on. We are very focused on quality, and it's not bespoke, jeweler quality. It is pride in workmanship, pride in craftsmanship. We create a good quality, good price product of the highest quality that we can possibly manufacture. So even the components that you don't necessarily see, to us, are a point of pride. So everything you see on this vehicle was well thought through. It's been gone over many, many times, and there is a QA/QC process that is followed to the nth degree. And I don't think you will see this on anybody else's product. And you don't need to believe me, just look at the reviews for the company. I mean, when you have this level of detail, it proceeds through in the feel and the rideability and everything from the way that you perceive it to the way that you feel, the visceral feeling.
Well, I'll tell you what, one of the things I want to point out is this right here. See this screw right here, or this tapped hole? You drill all the way through and tap it. And I have been to so many different companies and they drill it in so far and then they tap it, blind tap it, and then they tell me that they have problems with torque monitoring. Why didn't you just drill it all the way through? Oh, well, we can't do that. Why? Well, it'd be unsightly. Well, I don't think you're correct on that. It's got a case. It's going to be covered up. Why don't you drill it all the way through? Well, it'll take longer. No, it takes longer to bottom tap. On and on and on and on. All these myths, I don't know where they come from, but that's a cool idea.
And that's a very simple process.
And it's easy peasy all the time. It's amazing how many people who've been in it forever don't know that trick.
You can see here, so this is several iterations of our swing arm. This is when we went from all CNC to some of our hot forgings. So, that's one thing that really, really helped us early on was the cost of CNC coming down. So we didn't need to spend the money on tooling up 180 different parts right from the rip.
Yeah.
We had some leeway to do this. And even like parts we would traditionally stamp, until we get to 30,000 plus of these pieces, laser cutting is still more cost effective for us.
Yeah.
So the changing face of manufacturing right now is really, really interesting. So that's one of our robotic welded swing arms. It got a lot better.
Okay, good.
Yeah, so actually all of these, all the new chassis are our new robotically welded chassis.
These are
Obviously
still
TIG welding
bulky.
is amazingly beautiful. MIG welding, you definitely have a larger MIG, but still we've got to a point now where the chassis are looking absolutely amazing.
Yeah, and I think the one big change on the swing arm when we went to robotic welding and the hot forgings was the amount of welding. So the old steel laser cut pieces that we were doing before, they had about 50% more welds. So we actually cut, I think, 13 welds per side off of that assembly. So if we have to do those in-house, it's a much quicker process.
Yeah, so now we have an insert that
they're plugged insert instead of
really complex hand
cut
welds.
and then finished. We had a lot of detailed pieces because it was so visible that we had to compromise with early on.
And you can see the various states of assembly here. And then as we get to the end, this is another really interesting thing we ran into. Almost all of the dynos on the market right now read the pulse off the ignition. So to find an electric, to find an electric native dyno, we were going to have to put on our output shaft a timing sticker to then turn a digital signal to analog and then back to digital. So we got some really competent engineering students, interns from Case Western, Cleveland State, and one of their jobs was to build us an electrically native dyno with a full rolling road setup. So
Perfect.
We can spin up the bike, make sure everything's working before we take it out for 5 miles, 6 miles on the road. But this was something that was shocking to us because we could not find a dyno that really met our needs, or they'd be car dynos. You'd have a massive thing sitting in here. So we didn't plan on building one, but
That's the luxury of adversity.
there we are.
Yeah. Now you can go into the business of selling them to other people.
It'd
no,
probably
thank
be
you.
more profitable. Some of the dynos we were seeing were like upwards of $60,000 for something
this.
similar to this, and it was
Yeah.
just a little shocking.
Yeah.
Well, this is really a wonderful tour that you've given me. Unfortunately, we've got a 4-hour drive back, and I'm just looking at the time and went, uh-oh, I'm going to have an unhappy wife. So we're going to probably have to take off. But Scott, thank you so much.
Thank you.
I really appreciate the
Thank you for coming
tour,
by.
the information. I love the enthusiasm, the energy and whatnot. And I really am appreciative of having you let us come down and have a look. I'm sure you've got a very bright future.
Thank you.
And if I bump into anybody who's looking to dump money into a motorcycle company, you're the first choice.
Appreciate it. So there's 2 asks I'll leave you with. One,
What?
check out our website to anyone that's watching.
That'll be on the bottom, but go ahead. Yep.
Land.bike or landmoto.io.
Yeah.
And any investors that are interested in energy, mobility, anything to do with manufacturing, we're here, we're scaling. We've got product market fit, and we've got a lot of sales. We just got to keep up with it.
Cool. And I'm going to send you another guy, ASX, because he needs 5C kind of power to lift off a very large unit, and swapping battery packs out won't be a big deal for him.
Cool.
So
Appreciate it.
we'll see what happens.
Thank you, Sandy.
Alrighty. Thank you. Thank you, Scott. And thanks for watching, everybody. Stay tuned for more at Munro Live.